Hello, it's Mr. Humbard here. We're going to start with this video of the Chapter 3 review. For this video, we're going to start with our first problem, which velocity of the object is 0 at some point. We don't know what's true about the acceleration. So for this problem, acceleration can be 0 here. It could be like that. So our equation for acceleration is a equals v delta v over some delta t, change in time, change in velocity over change in time. And we want to know what could be true about it. It could still be accelerating though, if that's true, based on these cases. Right? So it could still be accelerating. For number 2, we assume the object has 0 acceleration. We want to know if it can be moving. If we have a velocity time plot, we can. So v and t, and if we are above the axis, like so, have a nice straight line, not going up, down. Here, make that a different color. We're not going up and down. We're traveling above the axis, say 2. So we're traveling at 2 meters per second, and we're not accelerating up and down. So we don't have a graph like that. We don't have a graph like that. All right. So this is positive. This is negative. For this one, our speed's going from 0 to 100 in 5 seconds. This is acceleration. So A, or acceleration. Number 4, we're going to assume the object is moving in the positive x direction. If the object is accelerating at this rate of 2, the object is going to be speeding up. Okay? For this one, if it's negative 2, it's going to be slowing down. If it is 0, it's not speeding up or slowing down at all. Alright, then we want to know if it's moving with constant velocity. What do we know about our acceleration? Well, acceleration must be 0 here because you have a constant velocity. You are not changing your velocity in time. So if we have the same velocity, vf minus vf, it's the same thing. If vi equals vf, then you have 0 velocity. Right. The object increases its speed at this average rate. This is going to be acceleration because it's meters per second squared. There's that s squared thing. And it's from 100 initial to final. V final, 180. So we want to use our equations. I will plug in my numbers first. So 180 equals 100 plus 20 times time, because I know that, this is a time symbol, that I got to use this equation based on the information given us. It doesn't give us distance. All right, now I'm going to solve this out. Subtract 100 both sides. 80 equals 20 times t. Divide out 20. This is multiplication. t equals 4 seconds. All right, for this one, we're going to solve it the other way. We have this initial speed 10. We have a constant acceleration a vi. We have this final speed. Okay, we're going to solve it the symbolic way. Use that same equation and subtract vi, t equals vf minus vi. Now we're going to solve this by dividing both sides by a. Find both sides by a. And then we're going to get an answer. So a equals, plug in our values. 25 minus 10 over 2. So a equals 15 over 2 equals 7.5. Or not a, time. Because I divided out a, didn't I? That's in seconds. Okay. Object travels 10 meters per second for 10 seconds. So this means initial, vi. This is for 10 seconds. It then speeds up with constant acceleration 2 meters per second for squared for 15 seconds. So during the acceleration, we use the time frame for that. Then we're going to plug our numbers in. So vf, we want to know its final velocity at the end of this time. So vi is 10 plus, using that same equation up here, whatever a is, looks like it's 2 times our 15, it's a time symbol, equals 30 plus 10, so 40. This is meters per second. All right. Number 11, we have an a value, accelerates, tells us right there. Starts from rest, that tells us v initial equals 0. Accelerate to its final speed. It's asking how much time. There's a right there. So our time value is just going to be using our sheet, or I'll solve it out. Vf minus vi equals at from the previous step on number 9 up here. We got up to here. And then instead of, we want time again, so we're going to divide out a. So time equals Vf 20 minus 0 over 2, or it's going to be 10. So 20 over 2 equals 10 seconds. All right. Physics concept. Position versus time graph. Velocity. Slope is velocity. This is acceleration. When it's a horizontal graph, on a position time graph, it's just not moving. It's at rest. When we are describing the motion of the object, when it's a velocity time graph, it's a horizontal line. That means that it's moving at a constant speed if it's above or below the axis. If it's at 0, it's not moving at all. So if we are on a VT, graph, and we're moving some straight line, pretend that's straight. If it's above, it's some constant speed. All right. Figure of the graph. Let's do it. Time. Average acceleration. All right. So for this one, we'll say we start it there. That's 1, 2, 3. This is 1 and 2. And we'll go up 2. All right. Our acceleration is going to be the same from both here since we have a uniform line. It's going to be rise over run. So 3 is our rise. Minus 1 divided by our run. 2 minus 0. We get 2 over 2, which is 1. Is our unit, meters per second squared. All right, for this one, a ball thrown straight up, 0 air resistance, with the acceleration at the time it's thrown, and I'm just going to do negative 9.81 for all of these. It's always acceleration due to gravity. And we're choosing negative because it's pointed downward in this case. Okay. So this one, it's thrown upward with a acceleration or initial velocity of 5. We want the velocity of the stone after 1 second. So upward is positive, tells you the positive direction here. That's a keyword, so we know downward is negative. And we know that we're going to choose to use our values here. For these, I'll just use negative 9.8. It might tell you differently in the problem. So V final equals V initial plus AT 5 plus negative 9.8 times 1, or negative 4.8 meters per second. So this time we have a bullet shot straight up in the air, turns the starting point in 10 seconds. We want to know the initial speed of the bullet when it leaves the gun, as it's leaving the gun. So like immediately after it leaves the gun. So right here, we know at the very top of the arc, this value is going straight up in the air, returns to the starting point. This is the entire period. So total time equals 10 seconds. We want half that time because that's the time to get to the top, and at the top, V final equals 0 at top. Once we know that, we should have everything we need because we also know G is negative 9.8. All right, so let's plug everything into that equation above, right up here. So we know that V final is 0 at top. We know that we don't know V initial. We add what our G is, negative 9.8. We use the fact that we have to use half of 10. So we want to get to the top. 5 divided by 2. And then we're going to find this, add this value to both sides. It's negative, we want to make that positive. So then VI is going to be 49. So pretty fast. Now 21. If we drop this object from a tall building, it takes this time to hit the ground. We don't know the height of the building. Usually when we're talking about heights, that's like the absolute value of the, because it's a positive number. You don't have a negative height usually. So, but we still need to use the displacement equation. So this one, v initial time plus 1/2 at squared. In this case, a is going to be g, of course. So there's our time, 3.1. We know it's dropped, so v initial has to be 0 at the start. Okay, so we plug all that in. We want to know delta x. 0 times 3.1 plus 1/2 negative 9.8. But since we want positive value, I'll just make that positive 9.8. And then here we'll do 3.1 squared. Get an answer here. And I'm going to get, looks like 47.089 meters. Let's do everything. All right. Now we have an object drop from this height of 30 meters. We want to know how long it's going to take the object to hit the ground. V initial still 0, dropped. Now delta x is 30 meters. Or your initial is 0 and your final's 30, however you want to do this. Or the other way around. Make it work. In this case, we want to know how long, so that's time. And for this time, we can't have a negative inside the square root, or negative in general, because we can't have negative times. So however you do this, I'll just make everything positive. We can't have negatives. So let's use the top equation, same thing we've used before. So I'll do 30 equals 0 times time, we don't know that, plus 9.8 over 2 times squared. Let's simplify that. That cancels. We get 4.9 times squared. We say multiplication. So 34.9 times squared divided by 4.9 divided by 4.9. That's a simplification. When I divide it out, oops. And then once we do that, that'll cancel 4.9 over 4.90, or not 0, 1, because it's just divided by itself. So t squared equals 30 over 4.9. We take the square root of both sides here because we want just t, not t squared. Right, and once we do that, we should get 2.474 seconds. All right. So this problem, it's kind of poorly worded, but won't be anything like that on the test. We're going to assume it starts from 0. We don't really know that, but just for the sake of this problem, because someone mentioned earlier about how the bullet thing is kind of confusing if this starts from 0. So using the idea of acceleration is our equation, because A equals delta V over T. Then we find that answer. Let me do that. And we should get a large value. All right, for the object in free fall, its velocity increases each second by what quantity? Well, g is 9.8. In this case, it doesn't matter so much that it's negative, because there's going to be multiple choice answers for the test. You shouldn't get this wrong if you confuse the two. And we care about the units now, because we just want to know that if you have something like a speedometer attached to this, the value of g is going to be the speed every time or every second that passes. You're going to increase your speed by 9.8. So that is our answer. All right, that's everything.